So in the last class we discussed about standard hydrogen electrode and its limitations. So the use of standard hydrogen electrode is, so you can use standard hydrogen electrode as a with one reference electrode. That standard reduction potential of that standard hydrogen electrode should be taken as 0. So by comparing the standard hydrogen with the other, you can determine the reduction potential of other electrode, because the standard reduction potential of hydrogen electrode is 0 ohm, right? And some of the limitations of standard hydrogen electrodes are: it is difficult to maintain 1 molar concentration throughout the experiment. It is difficult to maintain 1 bar pressure, and the standard hydrogen electrode consists of platinum foil, so that should be easily poisoned with the impurities present in the electrode. Okay. So next I will go for the measurement of EMF of a cell. Measurement of standard electrode potential. So already you know this one. So this should be calculated by considering EMF of this one is equal to EMF of cathode minus EMF of anode. So you already know that the EMF of a cell can be calculated by using this formula, that is nothing but EMF of a cell is equal to, it is a cell is equal to EMF of a cathode as well as the EMF of anode. For example, if you want to determine the EMF of zinc electrode, okay. So the EMF of zinc electrode can be determined by comparing the zinc electrode should be connected with the standard hydrogen electrode. So already you know that zinc electrode consists of a zinc or 1 molar zinc ion that should be dipped in a particular zinc sulfate solution, and that should be connected to the standard hydrogen electrode. That voltmeter shows the EMF, voltmeter shows 0.76 volt whenever you are comparing, that is zinc electrode with the standard hydrogen electrodes. So the voltmeter shows the EMF of 0.76 volt. So already you know this one, zinc will undergo oxidation, that is zinc, and that should be combined with hydrogen, that is H plus. So the formation of zinc ions and liberation of hydrogen gas in this case. So the EMF can be determined as EMF of a cell is equal to EMF of a cathode minus EMF of an anode. So EMF of a cathode, already you know that EMF of cathode in this case, this would be hydrogen electrode, anode should be this one, zinc electrode, because already you know that zinc will undergo oxidation, and cathode, that is hydrogen electrode, standard hydrogen electrode act as a cathode in this case. So therefore this can be written as EMF of H plus divided, that is H2 minus of EMF of Zn2 plus then Zn. Okay, so already you know that the standard hydrogen electrode potential of this hydrogen electrode is 0 volt, because this one acts as reference electrode, and the EMF that voltmeter shows is this much. So the EMF of this one is 0.76 volt. So therefore it should be minus of 76 volt. So this is nothing but minus 76 volt. So the EMF of cell in this case is 0.76 volt. Okay, so this is nothing but, so you can determine the EMF of a particular electrode or particular element by comparing one of the electrode with a standard hydrogen electrode, because the EMF of a standard hydrogen electrode is 0 volt, that is nothing but that will act as reference electrode in this case. Similarly you can determine copper electrode. So this one is already, this is according to your galvanic cell. So zinc will undergo oxidation, that will act as an anode in this case. So therefore the zinc will undergo oxidation with the liberation of therefore it will be absorbed by your hydrogen ions that is present in the solution, liberation of hydrogen gas. So this one is a cell, that EMF of a cell is equal to EMF of a cathode minus EMF of a anode. So this one is about 0 volt because this one is act as reference electrode. Then EMF of a anode, that because zinc will act as, zinc will undergo oxidation and it will act as an anode. So therefore the EMF of this one is 0.76. This voltmeter shows the EMF of zinc electrode as 0.76. Therefore the EMF of a cell in this case is 0.76 volt. Similarly you can determine copper also. So if you want to determine the copper, so that is copper 2 plus in this case, it becomes copper and it becomes 134 volt. Okay. So the same thing in this case. So here that is copper, it becomes 2 plus and it becomes H2 and it becomes copper and it becomes 2H plus. So therefore this could be written as copper 2 plus and it becomes a copper, it becomes H plus. So this becomes 0.34 volt minus 0 becomes 0.34 volt. Okay. So similarly you can determine that EMF of a copper electrode in this case by connecting with the standard hydrogen electrode. So in the first case you are determined that is the EMF of zinc connected with the hydrogen electrode. Similarly in this case you can determine that is EMF of a copper electrode by connecting with the standard hydrogen electrode. Here the standard hydrogen electrode acts as that is reference electrode, the EMF should be considered as 0. So therefore already you know that according to galvanic cell this copper will undergo reduction, that will act as a cathode in this case. Therefore this will undergo reduction, that is plus 2 to 0 in this case, and this will undergo oxidation, that hydrogen will undergo, that is oxidation. Therefore there is EMF of cathode minus EMF of anode in this case. The cathode in this case is, it will undergo reduction, therefore it becomes a copper, and anode it becomes in this case is hydrogen electrode, that becomes H plus H2. Right? Therefore already you know that the voltmeter shows the EMF of that copper electrode is 0.34 volt. So therefore 0.34 volt minus 0, because the EMF of that standard hydrogen electrode is 0 in this case. Therefore it becomes 0.034 volt. So you can determine, so by saying these example like copper as well as the zinc electrode, so you can determine EMF of an unknown sample by connecting with the standard hydrogen electrode because of that is reference electrode. That here the EMF should be considered as 0 in this case. So next I will go for the electrochemical series now. So already know that metal, when we know that metal and its ions will have a different electrode potential. Okay, so metal will have a different electrode potential as well as with respect to their ions and also a different reduction potential. So in order to determine the respective like electrode potential of a particular metal as well as its ions, the electrochemical should be followed. So that what is that electrochemical series is nothing but that is arrangement of various elements in the increasing order of their standard reduction potential. That is nothing but arrangement of various elements, arrangement of various elements, arrangement of various elements the increasing order of the standard reduction potential values. The standard reduction potential values. And this one is called as electrochemical series. This is also called as active series. That is, in this case, already know that metal and its ions will have a different electrode potential. So because of that one, that electrochemical series has been obtained. That electrochemical series is nothing but this arrangement of various elements in the increasing order of the standard reduction potential values. And this one is also called as active series also. So these are some of the example with the standard electrode as well as their reaction, then their reduction potential. So here, that is reduction potential goes on increases, that is increasing order of their standard reduction potential values, and this series is called as electrochemical series. So already you know that whenever it undergo oxidation, it becomes anode, and whenever it undergo reduction, it becomes a cathode. So therefore, in this case, by comparing this electrochemical series, so you can determine oxidizing as well as reduction power of a particular element as well as a particular metal ions present in the solution. So you can determine that is liberation of hydrogen gas whenever it reacts with the acids, and you can determine the stabilities of a redox reaction. So some of the applications of this electrochemical series are, so you can determine the first application, that is applications. The first one, so comparing the relative oxidizing or reducing powers of various substances. Okay. So in this case, a substance with higher reduction potential, substance with higher reduction potential, undergoes reduction. Acts as oxidizing acid. Right? So this one is the first application of that electrochemical series. So comparing the relative oxidizing as well as reducing powers of various substances. So that is nothing but a substance with a higher reduction potential will tend to undergo reduction, means that will be available in terms of ions, and that will act as the best oxidizing agent. So if you compare this electrochemical series from lithium to that is fluorine. So here the standard reduction potential of that fluoride is nothing but that is 0.2 plus 2.85 volt. This is the highest reduction potential in case of electrochemical series. So therefore it will tend to, that is, undergoes reduction with the liberation of F minus ions in this case. Therefore it will be act as best oxidizing agent in the electrochemical series, because their standard reduction potential of that is F2 or F1 is will have a higher value, that it will act as the best oxidizing agent. So means F2 becomes best oxidizing agent in this case. F2 is strong oxidizing or best oxidizing agent, strong oxidizing agent, strong oxidizing agent, and lithium, it is strong reducing agent. Why is strong reducing agent in this case? Right? So F2 is, that is best oxidizing agent or strong reducing agent, and lithium will act as a strong reducing agent in this case, because the standard reduction potential of that lithium is minus 3.0 volt in this case. It is a very less as compared to that standard hydrogen electrode. This is very less as compared to this standard hydrogen electrode in this case. So because that standard hydrogen electrode potential of hydrogen electrode is 0 volt, therefore it is less than that standard hydrogen. Therefore this will act as best reducing agent, and this will act as best oxidizing agent because of the reduction potential value is that is more in this case. This is the first application, and second one is calculating the EMF of a standard electrode potential, calculating the standard electrode potential. So already you know the formula. EMF of a cell is equal to EMF of a cathode minus EMF of a anode in this case. Okay. That is substance with higher reduction potential, substance with higher reduction potential will act as cathode, or substance with higher reduction potential acts as cathode. Fine. So this one is second application of electrochemical series, that is calculating the standard electrode potential of by comparing the two electrodes in this case. Which one should be considered as cathode and which one should be considered as anode in this case. So you can determine the EMF of cell. So substance with a higher reduction potential will act as a cathode in this case. For example, if you consider this one, zinc as well as Fe. So EMF of a zinc is how much? EMF of a zinc is minus 764 volt in this case, right? And EMF of that is Fe is how much? That is 0.44 volt. Okay. So which one is higher reduction potential in this case? This Fe becomes higher reduction potential because of that negative value in this case. If it is opposed to, this will act as, that is cathode, but in this case it becomes a negative in this case. Therefore this will act as cathode in this case because of high, that is least value with a negative. So this becomes a cathode and this becomes an anode. So by knowing the values, so you can determine EMF of cell in this case. Okay. So you can calculate standard electrode potential by using this formula. So substance with a higher reduction potential will act as a cathode. So therefore, in this case, by comparing the two electrodes in this zinc as well as Fe, so Fe has, even though it has the lowest reduction potential, but it has a negative sign. Therefore, it has a highest reduction potential. Therefore, this will act as a cathode and this will act as a anode in this case. This is second application. So third one is capability of a metal to liberate hydrogen gas, So capability of a metal liberate hydrogen gas when reacts with the acid. So that is nothing but whenever a metal reacts with H plus ion that is present in the solution, so liberation of hydrogen gas. Mn plus it becomes liberation of hydrogen gas in this case. So in order to liberate a hydrogen gas, in order to liberate this hydrogen gas, in order to liberate it, that is whenever a metal reacts with the acid, so there is a liberation of hydrogen gas. This is possible whenever the EMF of that metal ion, should be less than, should be smaller than EMF of H plus H2 right? So in order to liberate the hydrogen from a metal, okay, the EMF of a metal should be smaller than EMF of a hydrogen. So this indicates that the metals that is present above hydrogen in a electrochemical series liberate a hydrogen gas whenever it will react with the acid. Okay, I will repeat. So in order to liberate a hydrogen gas from the metal, so the EMF of a metal ion should be smaller than EMF of a hydrogen. So already you know that EMF of hydrogen electrode is 0. So it should be less than 0 means it should be in terms of a negative value. So therefore the metals that present in the above hydrogen in an electrochemical series that will liberate a hydrogen from reaction with the acids in this case. This one is the third application. And fourth one is comparing the feasibility of redox reaction. Comparing the feasibility of a redox reaction. So for example, so that is zinc 2 plus becomes copper, then Zn2 Zn it becomes copper 2 plus. So already know that EMF of Zn2 plus it becomes 0.76 volt minus 0.76 volt, and EMF of copper 2 plus is 134. Okay, whether this reaction is feasible or not, or it is nothing but whether it is a spontaneous reaction or so you can determine spontaneity of a reaction by comparing these two values. So by comparing the standard reduction potential values, you can determine the feasibility or spontaneity of a reaction. So if you consider this one, whenever a zinc, in this case, zinc will undergo reduction, copper will undergo oxidation. So the EMF of a zinc electrode, you know that minus 0.76 volt, and the EMF of that copper electrode is 0.34 volt. So which one is greater in this case? This copper is greater electrode potential compared to this one. Therefore, the zinc will not oxidize that copper in this case because of the reduction value of zinc is very less as compared to that copper electrode. Okay, so therefore this indicates that zinc ions cannot oxidize. Zinc ions cannot oxidize. Zinc ions cannot oxidize copper in this case. Why? Because the reduction potential value of that copper electrode is high in this case. Right? So therefore it will, the vice versa will take place. Means the copper will oxidize that zinc in this case, but zinc will not oxidize the copper in this case. Okay, so this is about your applications of electrochemical cells. First one, you can determine that is best strong oxidizing agent as well as strong reducing agent by comparing the standard reduction potential values. Means higher the values of standard reduction potential, that becomes a strong oxidizing agent. Lower the value of standard reduction potential values, that becomes strong reducing agent. So you can determine that electrode potential. So EMF, the substance with which will have a highest reduction potential will act as a cathode, and substance with a lower reduction potential values will act as anode in this case. So and third one is, so you can determine which metal will liberate hydrogen gas whenever it will react with hydrogen. A substance with a lower reduction potential means the negative, the substances that are present in the above electrochemical cities, that is in terms of negative values, will liberate a hydrogen gas from a acid. And the last application of this one is the comparing the feasibility of a redox reaction, whether this reaction is a spontaneous or not. Means whether the zinc will oxidize a copper or not in this case. Zinc will not oxidize the copper because the reduction values of that copper electrode is high compared to this one zinc in this case. So this will not oxidize copper in this case.